So we hear all the time that AI is completely changing science, right? But what if I told you there's this massive hidden flaw in pretty much all of them, a problem that's actually holding back the next big breakthroughs?
Think of it like this. You've got this absolute genius who can solve any problem you give them. But the second they're done, their mind is wiped clean. Poof, gone. They forget everything. That's basically where most AI scientists are today. They're these brilliant amnesiac geniuses, and it is a huge waste of time and energy.
So what's the fix? What if, instead of starting from zero every single time, an AI could actually remember and learn and build on its knowledge? What if we could give it a permanent, always-growing brain for science? Well, that's the big, game-changing idea behind a new framework called Idea2Story. All right, so let's really dig into this problem of the Amnesiac AI. This incredibly powerful tool that's just stuck in a loop, unable to remember what it's learned.
This slide just lays it out perfectly. On the left, you've got the old way. This is where AI tries to figure everything out on the fly, in real time. It's super slow, costs a ton of computing power, and honestly, it can lead to the AI just making stuff up, hallucinating. But then, look at the right. This is the new way, the Idea2Story approach. You build that knowledge base before you even ask a question. So it's fast, it's efficient, and it's way more reliable because it's working from a brain that's already packed with good info.
So how do we actually make that leap? How do we get from that slow, forgetful way to this much smarter approach? Let's get into the solution. And here it is, Idea2Story. The key phrase is right there in the definition. It's all about shifting the work. You stop doing all the heavy thinking on the spot, and instead, you focus on building a permanent offline knowledge base. You do all the hard work up front, creating this amazing brain that can be tapped into instantly.
I love how this visual breaks it down. It's really a two-step dance. On the left, you have the offline stage. This is where the AI basically does its homework. It reads and digests thousands of papers to build its brain, what the researchers call a knowledge graph. And then, on the right, you have the online stage. A person like you or me comes along with a vague idea, and the AI uses that pre-built brain to spit out a full research plan. It's so simple when you think about it. Build the brain, then use the brain.
So let's get into how that brain is actually put together, because this offline part, this is really the secret sauce to the whole thing.
It really boils down to three main steps. First, they build a massive paper pool, gathering and cleaning up thousands of the best research papers out there. Second, they do something called method sampling. They basically deconstruct those papers to pull out the most important ideas and techniques. And finally, step 3, they build the knowledge graph, organizing all those little pieces of knowledge into a structured, connected, usable brain.
And just so we're clear, we are not talking about a small weekend reading list here. This knowledge base is built from around 13,000 papers from the world's absolute top AI conferences like ICLR and NeurIPS. So this isn't just any brain, it's a brain trained on the best of the best.
This visual is just perfect. You can think of Idea2Story as this deconstruction funnel. You pour all these super dense, complicated academic papers into the top, and the system just filters and breaks them all down, neatly pulling out the core ideas, the key methods. It literally turns academic chaos into organized, structured knowledge.
And this is the result of all that work, the knowledge graph. Seriously, you can think of it as a giant mind map for science, or maybe even a massive Lego set of scientific ideas. See, the green nodes are the big research areas. The blue nodes are specific patterns or methods, and all those little red dots are the individual papers themselves. It's this huge interconnected web of scientific knowledge all ready to go.
Okay, so the brain is built, it's full of knowledge, now for the magic. Let's see what happens when we give it a simple human idea and ask it to turn that into a full-blown research plan.
Okay, here's a real-world example they used in the paper. A user comes in with a pretty simple idea. I want to build an e-commerce agent that can better understand user intent. You know, it's a good starting point, but it's super vague. It's definitely not a research plan, at least not yet.
So what does the system do? It takes that simple idea and immediately dives into its knowledge graph. It starts searching for all the relevant methods and patterns related to e-commerce and understanding users. It's not starting from scratch. It's just finding the right Lego pieces from its giant collection and starting to snap them together.
And you know, this isn't just a simple keyword search. It's way smarter than that. The system uses what's called multi-view retrieval. It looks at the problem from all these different angles at once. It finds similar ideas from the past, it figures out the exact research domain, and it pulls up the most relevant papers to make sure the final plan is totally grounded in real science.
Now this all sounds great in theory, but does it actually work any better than what we have now? Well, it's time for an AI idea showdown. Let's see the proof.
This table just says it all. On the right, you've got a research plan generated by a standard large language model. And it's fine. It suggests a pretty basic approach. But now look at Idea2Story on the left. It proposes something way more innovative, unifying diffusion models with graph embeddings. It's not just suggesting a small improvement, it's suggesting a totally novel approach. And it can only do that because it's pulling from that deep, interconnected knowledge graph we talked about. So look, this is about way more than just generating better research papers. This could change the entire engine of scientific discovery itself. If you take just one thing away today, let it be this. This is the whole story. We are moving away from this world of disposable, single-use reasoning, and we're moving towards creating permanent, reusable knowledge for our AIs. It's really the difference between building a sandcastle that gets washed away by the tide every single day and building a library of knowledge that stands for generations.
And that brings us to a huge, maybe even a little bit of a scary final thought. We are building AI that doesn't forget. An AI that learns from the sum total of human science and connects ideas in ways our brains just can't. So the question we have to start asking ourselves is, what happens when this permanent, ever-growing brain actually gets better at scientific discovery than we are? What happens when AI can finally out-research humanity? I'll leave you with that.